Hello and welcome to my podcast on interpreting depositional environments. The principle of this coursework is to become a landscape detective by applying remote sensing skills and geological knowledge to explore different landscapes, including desert, river, and deep marine in this coursework. Discuss different surface process and depositional settings in order to deduce the potential rock deposited in different environments by the different process. The aim is to investigate three locations which are listed below. The first location is in Hasi Mesod, and it's a hyper-arid desert zone which is located in Sahara Desert of Algeria, undergone extensive sedimentary deposition. This location was dominated by trees and grassland from about 10,000 to 5,000 years ago. Ergs cover 20% of the Sahara and most of Algeria, including this location, and it has many different types of sand dunes, such as transfer dunes and star dunes, which can be shown in Figure 1. It has other desert features such as sand sheets, ripples, and drafts which are produced by wind process. And dune field cover in this location size about 21 kilometers long and 15 kilometers wide. The main process in this location is airline process, and it is the main driver of deposition and transportation in this location. Wind deposition results in the formation of different sand dunes, and also wind transportation includes surface creep, siltation, and suspension from bed load to suspended load. Also, the wind erosions includes deflation and abrasion, results in the formation of yardans and desert pavements in other nearby areas of the Sahara deserts. The dune fields is classified as a depositional environments, and the axis of sand dunes are transverse to moderate winds and parallel to strong winds, and dunes move along with the wind direction. The potential rock type in this location is coarse arenates that is deposited by the wind process, as the wind can carry sand-sized grains effectively, and only the most resistant grains, mainly quartz, is likely to be accumulated in the dune fields due to the long-distance transportation. The Figure 4 shows a sketch of this rock sample with detailed annotation. This rock is well sorted and well rounded, and it's quartz dominated with about 90%. And also it has cross-bedding structure that indicates the wind direction. Compaction shows the reduction of the pore space, and in this rock sample is less than 10%. The second location shows a meandering river system, and the specific coordinates indicates a mid-channel point bar, which is created by the longest river in Italy, Po. Po has most meandering and braided characteristics, and this is a type of meander feature. The bar is formed driven by downstream and lateral accretion. Uneven sediment is transported by the turbulent flow that will produce a sedimentation erosion pattern, and it causes bifurcation around the point bar. It has many point bars along the inner band of the stream. In this point bar, a cut-off chute is developed, and also it produces a new channel with an island near the river band. It also has floodplain, which is the broad area depositing mainly fine-grained sediments along the channel. The surface process in this location is mainly fluvial process, and it includes erosion, transportation, flooding, and deposition. Maximum erosion occurs in the Mount Viso mountain, where Po originates, and also lateral erosion occurs on the outside of the bed and cut bank. Transportation includes bed load, suspended load, and potentially solution. And in flooding, the velocity of current is the lowest at the edge of the channel, and deposition occurs when the water flows slower in the shallow area near the inner side of the stream. And the meandering river is a type of depositional environment. The river flows faster in the outer edge of the curves, and it will deposit normally accumulate around the inner bank, and it will create point bars. And also on the floodplain, there will be fine-sized grains such as silts deposited as well. The main sediments can be deposited in the meandering river system are clay, silts, and sand-sized grains, as the meandering river is mainly moderate to low energy environments. So the main rock types in these locations are siltstone, lithtic arenates, and mudstone. And Figure 8 to Figure 10 shows detailed sketch of the rock samples with annotation. The silts are deposited from suspension carried by the river, and also the siltstone is formed near sandstone deposits, as the silts deposit above the point bar sand near the floodplain, and also the silts can be formed in the floodplain away from the channel during overbank flooding. This is a mixture of quartz, feldspars, micas, and clay minerals, and it contains more than 66% silver grain-sized particles. It can also have ripple marks, which are caused by water flowing over loose sediments. Lithic arenates is formed when the source is nearby with a variety of rock types, as it has significant component of unstable lithic fragments, which makes the rock texturally and compositionally immature, with poorly sorted grains. As the river carry lithic fragments over short distance through bed-load transportation, which are deposited in the meander loops with slower water flow, and the rock is mainly cemented by calcites, and also it has cross-lamination, which are caused by the straight migrating ripples. The mudstone can be also formed when the clay-sized clasts are transported from suspension in the water flow over a long distance from the source area, and the flooding causes the water flow to slow down significantly over the floodplain. Therefore, the clay accumulates on the low-energy floodplain over time and is lithified into the mudstone, and it's a mixture of clay minerals and its class-supported framework. And the last location is located in the North Atlantic Ocean, surrounded by the Canary Islands. The Canary Islands are a group of volcanic archipelagos that have long-lived volcanic activities. The eruption on Tenerife in 1909 has caused some potential impacts on the nearby marine topography around this location. This location has depths about 1,100 meters and is classified as a deep marine environment. It encompasses the continental slope and towards the continental rise. This location is about 6 kilometers away from the coast. The surface processes in the deep marine environment cover the location includes turbidity current process, lava flow, mass wasting, deposition, and pyroclastic flow. Turbidity current process is a type of sediment mass movement that will erode sediments through submarine cannon, and it results in graded bedding and it transports volcanic materials, where the most deposition occurs in the submarine vein, which is further away from the Canary Islands, where the velocity decreases dramatically. Lava flow is caused by the volcanic activities in the Canary Islands, and it flows directly into the sea to form hydroclastic sediments, where lava contacts with water and causes rapid cooling. The lava flows downslope to the deep marine, and it forms pillow lavas on the ocean floor. Mass wasting is a gravity-driven movement, such as debris flow, landslide, and slumping, and it operates without water and air, and also transports volcanic materials from the volcanic activities. Deposition occurs mainly in the low-energy environments, and it has accumulation of sediments, such as wind-blown dust from the Canary Islands, hemipelagic sediments, volcanic ash, hydroclastic deposits, and so on. Pyroclastic flow is also a type of surface process caused by the volcanic activity, and the flow deposits volcanic ash and debris, and it has fast-moving currents of hot avalanches and ash. Deep marine is a type of depositional environment, and it has continental slope mainly in this location, which extends from the continental shelves, and also has submarine vein, which is near the location further away from the Canary Islands. The potential rocks formed in the deep marine cover this location includes tuff, volcanic breccia, chalk, and also turbiditic quartz sandstone, which is formed further away from the Canary Islands, mainly in the submarine vein. As the Tenerife, which is part of the Canary Islands next to the location, is a type of stratovolcano, it produces both lava flow and a pyroclastic flow, and it has fine-grained volcanic clasts and volcanic ash that are deposited in the deep marine, which then lithify to form the volcanic clastic rock, which is tough. And this rock is relatively soft with high porosity, and also it has pyroclastic texture. Also, volcanic breccia can be formed as a type of volcanic clastic rock as well, predominantly of angular fragments resulted from brecciation, and it is compacted from fragments dominated of ash that can be transported through gravity-driven flow, such as landslides. Chalk is formed when there are deep-sea microorganisms remain in the seafloor around this location, and it is formed from coccoliths, which accumulates as oozes in deep marine, combined with compaction and burial, and also is a non-clastic sedimentary carbonate rocks made up of calcium carbonate. Turbiditic quartz sandstone is formed in the ocean floor, and the sediments deposited from the turbiditic currents in deep marine. Turbidity are characterized by a Bullmark sequence, and in this rock it has parallel bedding, which indicates the lithology of sandstone. In summary, in this coursework, I explored formation, composition, and the texture structure of different sandstones, volcanic clastic rocks, and the limestone in different depositional environments by utilizing the sketches and the rock annotations. In terms of surface process, I found processes such as deposition, transportation tend to occur in a majority of different depositional environments, and this process are key to shape different landscapes. And also, different surface processes cause different sediments to be deposited with a variety of energy. Coarser grain sediments tend to deposit in high energy environments, whereas finer grain sediments tend to deposit in quieter environments. And then it brings to the end with all the reference covered in this coursework. And here is the end of my video podcast. Thanks for watching.